So the question 11 says the structure of three members of a homologous series called the dienes as shown. Okay, so this is one of them, this is the second, and this is the third one. So the general formula for dienes, that would be option D, because diene and alkynes share the same formula. Okay, CnH2n minus 2. And cycloalkanes and alkene share the same formula, CnH2n. And alkanes have the formula CnH2n plus 2. Okay. And then question 12. Which of the following formula mass belongs to a hydrocarbon that does not belong to the same homologous series as the others? Okay, so each homologous series different from the varies from the other by a CH2 group, be it alkane, alkene, alkyne, whatever you. Okay, so in essence, methane is different from ethane by a CH2 group, and ethane from propane by a CH2 group. Okay, so it's just more like the addition of CH2 group. And CH2 group, the relative mass of carbon is 12, and that of hydrogen is 1. But since we have two hydrogens, it's 2. So when we add this together, we have 14. So in essence, the difference between this methane and this is the addition of 14 more atoms. Okay, 14 more masses rather. So for this one, the option, let's take the option 16. So if we are to add 14 to 16, we have 30. And if we are to add 14 to 16, we have 30. If we are to add 14 again, we have 44. If we are to add 14 again, we would have 58. And if we are to add one more 14, we have 72. Okay, so from here we can see 16, we can see 30, we can see 44, 58, and 72. So I believe the odd one out here is 70, because 70 is less of 2 masses. Okay, and then the question 13, the structural formula for a compound is this. So the name of the compound would be what? The most primary thing here is how many carbon atoms do we have? Okay, and then what is the functional group? The functional group here is this group, which is a carboxylic group, an acidic group. Okay, and the total number of carbon atoms here is 4, because we have 4 carbons. So and 4 represents a boot, and then the functional group is an acid, so this would be a butanoic acid. So when you're counting the total number of carbon, you include even the carbon of the functional group. So we don't get to say this is propanoic acid. We would include counting the carbon of the functional group. And then question 14 says the shortened structural formula of the compound is shown this. Okay, so which of them is that same compound? So it's more like representing this in a more open way. Okay, and so to do that is carbon attached to 3 hydrogen. What we just drew now is this. Okay, and the next is a CH, so the next carbon having just one H. Okay, and then the next carbon is a C. The next carbon now is having a OH group, OH. If you notice, every carbon carbon should be attached to 4 bonds around it, but this carbon has only 3 bonds around it. So that tells us that there should be a double bond here, so that this carbon number 2 would have a complete 4 bonds. Okay, and then this bracket represents that the group inside belongs to the carbon before it, which is this carbon number 3. Okay, and then the next we have the next carbon, which is carbon number 4, attached to CH3 groups 3 times. So we have 3 of CH3 attached to the same carbon. So we have CH3, CH3, and then CH3. So we'll put into consideration these main carbons. These are the longest carbon. These are the main carbons. Then all these things within in brackets, they are groups. But when it's just hydrogen, it's not necessarily being placed in a bracket. But if it's any other group other than hydrogen, that's when it's being placed in bracket. So of all this option, A gives us the answer. Option B is giving more hydrogen to the second carbon atom than it is said in the question. Okay, so the second carbon atom is having just one hydrogen, but here it's having 2 hydrogens. Okay, 2 hydrogens, and it's having a single bond. Okay, and then option C is also inaccurate because they gave an additional carbon. Okay, so this carbon did not exist in the question. Okay, and this is because of the double bond. And then option D is inaccurate also because there is no double bond and they gave additional hydrogen, which is not supposed to be there. And then question 15 says pentene reacts with water to form two products. So pentene, generally all pentenes generally do this. Okay, so when it does this, what happens in this reaction is that an OH group breaks this, the water breaks this bond, and then a OH is placed here, and also a OH is placed. So where the double bond is, an OH group is attached to those two carbon atoms in concern. Okay, so if we say but one in but one in, this is our but one double bond here. So when this reacts with water, there will be an OH group here, and there will be in the for the first product and the second product we have an OH group here. In the first product we have a single bond and then an OH group in one of the carbon. Okay, then the second product will have a single bond and then an OH group here. Okay, so these are two different compounds. But for but2-ene, the double bond is at the middle after the second carbon atom. Okay, this is what makes it but2-ene. Now when the water reacts, okay, this bond is now broken and there will be an OH group here. And in the second product, the bond will be broken and then there will be an OH group here. This will no longer be here. Okay, so this is our option because this is the correct option because the two products are the same thing if you are to name them. Okay, because they are both in the second carbon atom. Okay, based on homologous rates. So this is also the same as this. So we are not getting two different products for but2-ene, unlike but1-ene and the other options, and even the one that has been given as example. These are two different options. Here the OH is in the first carbon atom, and here it is in the second carbon atom. Okay, but for this but2-ene, the OH group would be in the second carbon atom in the both cases. Okay, it's unlike this that will be in the first and the second. It's in the first and the second, like that.